Lesson 1.4 is about angles. An angle is a figure formed by two rays that share the same endpoint. We call the endpoint the vertex of the angle. And we call the rays the sides of the angle. Now, in this angle at left, there's a couple ways we could name this. We use that symbol to mean angle. We could call this angle B just by naming its vertex. Or we can name a point on each side and the vertex in naming the angle, and we always put the vertex in the middle. So we could call this angle ABC, or we could call this angle CBA, using three letters. What's important is that this B, the vertex, is always in the middle. Okay, if we're using three letters, we put the vertex point in the middle. Okay, there are four angle classifications based on the size of the angle in terms of degrees, the measures of the angle. So an acute angle is less than 90 degrees. A right angle, the two sides are perpendicular to each other, is exactly 90 degrees. An obtuse angle is between 90 degrees and 180 degrees. So it's not 90 and it's not 180, but it's something larger than 90 degrees and smaller than 180 degrees. And then, of course, a 180 degree angle, that's what we'd call a straight angle. The vertex right here, the sides of the angle actually open up all the way, and we form what we call a 180 degree straight angle. So every angle will fit one of those criteria. Okay, now, much like the ruler postulate, when we're talking about segments, we can use the protractor postulate to measure angles. And if we were to line up the vertex of an angle, any angle, and in this case, say we're talking about angle AOB, if we're to line that up with a 0 on a protractor, which you know is a semicircle with degree measurements in it, and we want to know what's the angle measure of AOB, and we say measure with this little M in front of the angle sign. So anyway, we put the M in front of the angle sign. It means the measure of angle AOB. And so let's say that on our protractor that A corresponds to 80 degrees and B corresponds to 20 degrees. Well, then the measure of angle AOB, I'm sure you've already figured this out, is the absolute value of the difference between where those sides go through on the protractor. So 80 minus 20, or it doesn't matter since it's absolute value, it's distance, which direction we subtract these in, or the absolute value of 20 minus 80. So the measure is 60 degrees, and that's the protractor postulate. Okay, and then again, much like the segment addition postulate, we have the angle addition postulate. And in segment addition, remember it was important that that one point B be between A and C for the two segments to add up on the same line. Well, in this postulate, point B has to be in the interior of the angle, so inside the space between the two sides of the angle. So in this case, say in the angle I've drawn here, if point B is located in the interior between AOC and we put a ray through point B and we divide AOC into two angles, then what follows is that the measure of the top angle AOB, when added with the measure of that bottom angle now, BOC, you've probably already guessed it, will be equal to the total measure of the original angle AOC, the big angle. So small plus small equals big. So, you know, if AOB was 10 degrees and BOC was 40 degrees, then the entire big angle would be the sum of those two, or 50 degrees. And then a special case of the angle addition postulate is when we have AOC, as we can see right here, Angle AOC is what we would call a straight angle. And when that's the case and B lies a point that's not on AOC, if we draw a ray from a point on, and we have AOC and we draw from a ray from A through B, we create what we call a linear pair. And that's these two angles, AOB and BOC, are going to be a full 180 degrees. So in a special case of angle addition postulate, if we have what we call two angles that are a linear pair, like these two, together they form a straight line, then we know that the sum of those two angle measures is 180 degrees. Okay, and then just the way that line segments can be congruent because they have equal length, when angles have equal measure, then we say they're congruent. We use the congruent symbol. So I can write that if I just want to talk about the measure, the number of degrees, I can use an equal sign. I can say the measure of angle R is equal to the measure of angle S, which in this case, they're both 40 degrees. Or if I don't want to use that measure and I just want to talk physically about the angles, then I would use the congruent symbol. I would say angle R is congruent to angle S. So when I'm talking about the physical figures themselves, I use the congruent symbol. When I'm talking about their measures with the little m in front, then I can use the equal sign. Okay, a few more terms. When we talk about adjacent angles, we talk about two angles that are right next to each other. They share a common endpoint. So in both these cases, 1 and 2, angles 1 and 2 have the same vertex, but the angles share one common side, but no common interior points. So they're just right next to each other and they don't overlap at all. So in both these cases, 1 and 2 are what we call adjacent angles, common endpoints and no overlapping interior points. Okay, next and last we have an angle bisector, and the definition of an angle bisector is it's a ray that comes out of, well, I didn't do that very well. Okay, I've redrawn it. That red ray bisects angle AOC. So let's just put a point on that so we can name it. So that ray is what we call an angle bisector. It divides the big angle into two congruent angles. So from this I could say that angle AOM is congruent to angle MOC. And that's the definition of an angle bisector. And that's it.